Hello and welcome. My name's Gordon. It's great to have you with us. Today we're going to do some practice questions on the City and Guilds 2365 602 Electrical Science exam. Now, for those who are not familiar with that, that is going to come in your centre study when you come into the centres, either on week 2 or weekend 5. Okay, so we're going to be basically going through a series of questions which will give you experience of answering online questions just like you will in the GOLA exam, but also we're going to give you lots of other information as well as we go through. Now, as you've probably gathered, if you've been on one of these before, we don't have a host. So I'm going to be doing the chat as well as doing the questions and the explanations as well. So bear with me. Might get a little bit confused, might get it wrong way around, but who knows? If you're on a computer, obviously you'll be able to hover your little mouse over the questions and answer. If you're doing the answering the questions via your mobile phone, obviously you need to use your finger to press and answer the questions. Like I said, as we go through, in addition to me answering or giving you the questions, I'll also be giving you more information about the course and how we go along doing online exams in the centres as and when the centres get opened. Okay, so if we move on to the next slide. So if you haven't carried out the lessons, this is basically what we're saying is when you get invited into the centre, you'll be coming in straight away to do your actual exam, your online GOLA exam from City and Guilds. So everything we've been doing, all the live recordings, and these practice exams and all the other material being given you, such as Smart Screen and Trade Jobs, mate, they're all building you up to give you that in-depth knowledge. So when you come into the centre, you can actually take that exam first time and pass it first time. What we don't want you to do is just flick through the centre study, tick, 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 thinking you're being a bit clever, you're passing everything online, but when you come into the centre, you really don't have that in-depth knowledge and you end up failing. That's not going to help you. Okay, we've all been in an unfortunate situation with lockdown where we've actually had a little delay in the learning. What we're going to do is accelerate that, and that's why we've been doing this since last March, all this online stuff to give you that great opportunity, that great start. So when you come in, bang, you take the exam and you pass it first time. Okay, so let's move on. So the practice test, just to reiterate what I'm going to do, I'm going to give you the question, give you the 4 set answers. There's 20 questions. We're going to do in 4 parts, so 5 each. And then at the end of each section, so after 5 questions, I'll then give you an explanation of which is the right answer and how you do it. Now, today being a science exam, out of the 20 questions, 17 of them are actually calculations. So I think if you tuned in early part of the week, we did say you need a calculator for this because some of them, especially the resistivity ones, you won't be able to do it in your head. Okay. Now, if you're watching this as a recording, so you're not watching it live, unfortunately, you won't be able to scroll through the actual questions live on screen. However, you'll be able to hear me say all the questions and the 4 separate answers. And more importantly, I think, is actually hear the explanation of which is the correct answer. Okay, so like I said, whether you're watching it live or watching it recorded, it doesn't really matter. You'll get the right answer, or you'll get a right explanation for the right answer. So without further ado, let's start with the first question. Which one of the following identifies the sources of electromotive force, or EMF, as we know it as? A, atomic magnetic thermal. B, chemical magnetic thermal. C, chemical atomic thermal. Or D, chemical magnetic atomic. Just answer that again, question that again. Which one of the following identifies the sources of an electromotive force, or EMF? A, atomic magnetic thermal. B, chemical magnetic thermal. C, chemical atomic thermal. Or D, chemical magnetic atomic. Now, straight away, that can be a bit confusing. There's a lot of the same words in that question, and this is why it's really important. But you actually read the question very, very carefully, because you might immediately be drawn to one particular answer because there's some words you recognize, but actually they're the same words which you read in another part of the question, another answer. So it's really important, but you read all the answers. Don't just jump to a conclusion, but B is correct or C is correct. Read them all before you make that decision. Okay. Let's move on to question number 2. Electrical current is described as a flow of what? A, protons, B, electrons, C, neutrons, or D, neutrinos. I'll repeat that again for you. Electrical current is described as a flow of A, protons, B, neutrons, or A, protons, B, electrons, C, neutrons, and D, neutrinos. Try and keep up with me on this in terms of don't jump ahead. Try and stay so we're all keep as a little pack together, okay? Okay, question number 3. First calculation question when we come to explaining. Okay, so make sure you get a pen and write this down. You probably need to get a calculator, a piece of paper, and write this down as I'm speaking. So question number 3. If the resistivity of aluminium is 2.65 times 10 to the power of minus 8, the resistance of a 65 meter length of 60 millimeter squared aluminium conductor is, a lot of numbers in there, A, 0.107, B, 0.0108, C, 1.108, D, 10.77. I'm getting confused just even reading those. So like I say, if you're not used to this, lots of numbers in an exam situation can be very confusing. That's why it's so important to read the question and pick out what it's asking you. Okay? It's asking you what's the resistivity. So you need to find the formula for resistivity. So I'll answer that question again. If the resistivity of aluminium is 2.65 times 10 to the power of minus 8, the resistance of a 65 meter length of 16 millimeter squared aluminium conductor is A, 0.107, B, 0.0108, C, 1.108, or D, 10.77. I said, remember back, you've probably all studied at various levels. Some will be a bit further in the course than others, but you've probably all done the smart screen material for this. So if you have done the smart screen material for this, and in your center study, you should know what resistivity is and you should know the formula for this. If you haven't, don't worry about it. You know, just have a little go at it. You'll catch up at some point as you move forward. Okay. Question number 4. The strength of the magnetic flux produced when current flows in a conductor can be increased by A, increasing the current, B, decreasing the current, C, reversing the current, or D, using alternating current. Repeat that again, question number 4. The strength of magnetic flux produced when current flows in a conductor can be increased by increasing the current, decreasing the current for B, C would be reversing the current, and D, using alternating current. That's the last of the wordy questions. Everything else now is calculations. So like I said, if you're a bit further on in your study, then don't worry. Some of the questions might be a little bit out of your reach. You might not understand them. You might not have come across them, but don't worry. Just have a go And at some point, as you move forward on the course, as you move forward in your TMAs, on your centre study, doing your smart screen material, this will all start making sense. And the beauty of this, at some point when you're ready to do it, you can look back on this 602 and have another go at it, because it's always going to be there in your website. Go on live recordings, and this will be up there so you can have another go at some point in the future. The final question in this first set, question number 5, another resistivity question. If the resistivity of aluminium is 0.017 times 10 to the power of minus 6, the resistance of a 100-meter length of 6 millimeter squared cable is A, 0.0003, B, 0.28, C, 0.09, or D, 0.48. Again, lots of numbers in there, very confusing. That's why it's important to have a calculator, a pen, and a piece of paper so you can scribble this down. And this applies even when you're in the center. When you're doing this for real on the online, you will be given a calculator, you'll be given a scrap of paper. And that's where you can do your calculations, your workings out before you pick A, B, C, or D. We'll just go over this one again. If the resistivity of aluminium is 0.017 times 10 to the power of minus 6, the resistance of a 100-meter length of 6 millimeter square cable is A, 0.0003, B, 0.28, C, 0.09, and finally D, 0.48. Okay, so the first 5 questions in the first section. So now we'll go on to explanations of those. Okay, shall we do that, or are we just waiting for the last couple? Okay, let's give the answers. For question number 1, the question for our answer for number 1 would be B. Okay, it's chemical, magnetic, and thermal. Chemical you get in batteries. Thermal is every time you put current through a conductor, it gets hot, and it also emits a light. That's part of the thermal part of the EMF of an electricity. And also magnetic. We use magnetic as motors and as transformers. If you didn't know any of that, you could look at that question. All these are very typical questions, by the way, from City and Girls. If you look at 3 of those, they've got atomic in. Reality, atomic, it's like nuclear. It wouldn't be a source of EMF. Okay. So straight away, if you didn't know anything about this question, you could probably take a calculator guess, but the ones with atomic in probably are not the right answers. Okay. So just to reiterate, question number 1, the answer is B. Question number 2, electrons or electrical current is described the flow of what? Well, it's actually B again. Electrons are the flow. You have basically the voltage pushes the electrons, which are the part of an atom, the bits what fly around, orbit the center nucleus, and they jump from atom to atom, and that jump in that flow of electrons ultimately is current flow. Okay. Protons and neutrons, they form the nucleus, so they're like the center of the atom where the electrons fly around. And neutrinos, actually, these are a real word. It's not something I've just made up, actually. Neutrinos are incredibly small particles, like you might have heard the word quarks as well, at the Hadron Collider in Geneva, that place where it's 27-kilometer tunnel, basically, a circular tunnel, and they fire electrons or fire atoms at each other. Explosions go off, and they find all these tiny subatomic particles. And a neutrino is one of those they discovered quite recently, actually. Okay, me waffling on. Question number 3. What's the answer to this? Lots of numbers. We're going to go to a formula for this. I'm going to take my little trusty board and my pen. I've brought it all the way from the south. So, what's the formula? If we can have the screen a bit bigger. Could we have the screen a bit bigger? It probably is. So I can't see. Oh, there we go. There we go. So the formula for this is resistance equals resistivity, and this is a fancy little word. It's like a P, but it's actually called rho, times length over area. When I talk about area, we're talking, whoops, we're talking, scrub that out there. We're talking cross-sectional area, okay, of the cable. So basically, we're just popping numbers into there. So we've got the resistivity of the aluminium cable. So that's 2.65 times 10 to the power of minus 8 times the length, which was 65 meters, divided by the area, which was 16 millimeters squared. And for those of you who've seen videos of this before, 16 millimeters squared, when we're talking about it, it's 16 times 10 to the power of minus 6. And that's why, as I said, you need a calculator, a scientific calculator, because to do that calculation in your head, you've got absolutely no chance of doing it. Okay? Now, on my calculator, to do this 10 to the power of minus 9, I go into my shift button, which is that button there. And then I have a little button, which is 10 to the x, which looks like that. Okay, so I press shift, that button, and then minus 6, minus 8, whatever it might do. Some calculators have an E or a big E, such as that, and it does the same thing. That's why you need to look at your instructions for your calculator and work out how to do this, because it's really important. If you don't know how to do that, by the time you come to your 602 exam, you're going to really struggle with this. So bottom line, that calculation, once you put 2.65 times 10 to the minus 8 times 65 divided by 16 times 10 to the power of minus 6, you'll end up with 0.107, which is answer A. Sure you all got that. Scrub this out, get ready for the next one. Okay, next question. Scroll down to the next question. The answer would be the strength of magnetic flux produced when current flows in the conductor can be increased by what? Well, the idea of magnetic flux, ultimately, when current passes through a conductor, it produces a magnetic field. So just thinking about it, the more current you push through there, the more magnetic field, or the bigger the magnetic field it's going to create. Okay, so if you think that logically, the answer's got to be A. Increasing the current increases the magnetic field. Okay, number 5, we've got another resistivity question. So we'll go back to the smart board, or the little whiteboard. Same formula again. Resistance equals rho, or resistivity, times length divided by A. Remember that formula. Realistically, in 602, there's probably about 10 formulas. There's lots more, but if you can remember the 10 core ones, that'll get you through that exam. Okay, this is one of them. Out of the 40 questions in the 602, I would suggest probably 3-4 of these are going to be in there. Given you only need 50% success rate, if you got 3 or 4 of these out of what, 20 questions, that's getting on for like 25%, you know, in round up numbers, you'll get through a pass just by knowing this formula alone. Okay, so if we put in the numbers, the resistivity was 0.017 times 10 to the minus 6 times, if you remember, it was a 100-meter cable, divided by, it was a 6 millimeter squared, but we always put 6 times 10 to the minus 6. Now, a little tip on this, sometimes City and Guilds are very, very nice. They have a really good day. As you can see on here, that's minus 6 and that's minus 6. Doesn't happen very often, but if it does, keep an eye out for it. And this is why it's important to keep looking at the questions carefully. If they are, you can cancel those out. And it just makes it a lot easier then to put the numbers into your calculator, because all you're putting in then is 0.017 times 100 divided by 6. So much easier messing about with these fancy numbers up here. It doesn't happen very often, but if it does, just cancel it. Makes life so much easier. And then if you put that into your calculator, you're going to get 0.28. Okay, clean that off again. Okay, let's go back to the next set of questions. The second set of questions, probably a better way of looking at it. So, a conductor of a simple alternator is 0.2 meters long and cuts a magnetic field with a magnetic flux density of 2 Teslas. Now, that's not the car, by the way. Okay. At a velocity of 20 milliseconds, the EMF, or the voltage, induced in the conductor will be what? A, 0.08 volts, 0.8 volts, 800 volts, or 8 volts. Now, this is a classic one where look at all 4 answers. They've all got 8 in them. That could be very confusing. So you just have to pop in your calculator 1 digit wrong, or the decimal place in one. For instance, where it's at 0.2 meters, if you put in 2 meters or 20 meters, that decimal place will give you a different answer. So it's so important when you're popping in the numbers on your calculator, you're doing it correctly. Otherwise, you're going to get one of these other alternative answers. So let's repeat that again. A conductor of a simple alternator is 0.2 meters long and cuts a magnetic field with a magnetic flux density of 2 Tesla at a velocity of 20 milliseconds. The EMF or voltage induced in the conductor, will be A, 0.08 volts, 0.8 volts, 800 volts, or 8 volts. Just to let you know, GOLA, we've mentioned this term GOLA quite a few times now. It stands for Global Online Assessment, something I only found out this week, actually. For many, many years, I've been calling them GOLAs, not really thinking they meant anything, but that's what it stands for. So when you come into the centres, when we talk about you're going to sit your GOLA, that's what it is. It's your Global Online Assessment, which is basically you're sat in front of a computer doing similar style questions to this, answering A, B, C, or D. Moving on to question 2. What is the force applied to a mass of 19 kilograms when subjected to gravity? The key word for this is, do you know what gravity is in terms of a figure? So answer A, 186.39. Answer B, 1.93. Answer C, 9.19. Or D, 28.81. I'll repeat that again. This is question number 2. What is the force applied to a mass of 19 kilograms when subjected to gravity? Again, that's one of those numbers you must remember. A, 186.39. B, 1.93. C, 9.19. Or D, 28.81. Also, just to let you know, we're going through some questions here. These are very, very typical questions, what you'll get from City and Guilds. But there's no point in just remembering these questions, and indeed all the other questions we've put on the online test before, because they're not going to be, they'll be amazed if they were, but they're probably not going to be the questions you're going to get in your GOLA on your actual exam when you come into the centres. City and Guilds have a huge bank of 600 plus questions. You could get asked any of those. Indeed, they're probably changing them all the time. Okay, so it's not just a matter of learning parrot fashion these questions and the answers. You need to know how to do the calculations. You need to remember the formulas. So for instance, that number, that 19 in the real world, very typical question, but in the real question, that might be 28 kilograms. If you've just remembered what the answer is to 19, you're going to get it wrong. Okay, so you must remember the actual formula. So question number 3. The power, this is quite a big question actually. The power required to lift a mass of 10 kilograms to a height of 15 meters in 20 seconds is approximately A, 7.5 watts, B, 4.9 watts, C, 74 watts, or D, 3000 watts. Looking at the answers coming through here, a lot of people have different views on it because it's a complicated question, this. So I'll just go through it again. Question number 3, the power required to lift a mass of 10 kilograms to a height of 15 meters in 20 seconds is approximately A, 7.5 watts, B, 4.9 watts, C, 74 watts, or D, 3000 watts or 3 kilowatts. It's a multi-stage equation, this. Okay, so if you're not doing it in a multi-stage, you're probably doing it wrong. There's several formulas which you need to do first and then link another couple at the bottom. It's probably as complicated a question you're going to get at City and Guilds in your 602. But I like these kind of questions. It's taxing. It makes you feel really good when you get the right answer. Okay, so let's move on to question number 4. A motor produces an output of 8 kilowatts. That's the K in there. If you didn't know, it stands for kilowatts, or kilo, should I say, which means 1,000. So 8, we could put 8,000 watts, but we always try to make things simple, so we use the word K. So 8 kilowatts. A motor produces an output of 8 kilowatts when the efficiency is 60%. What is the input power? A, 7940 watts. B, 480,000 watts. C, 4,800 watts. Or D, 13,333 watts. Just think about that logically, that question. What's going to be bigger, an output or an input? That's all I'm going to say. Just repeat it again. Question number 4, a motor produces an output of 8 kilowatts when the efficiency is 60%. What is the input power? A, 7940 watts. B, 480,000 watts. C, 4,800 watts. Or D, 13,333 watts. Okay, if you're not sure, like I said, just have a go. You're not going to be marked down, or if you get it wrong. It's all practice. It's all good practice. Question number 5. This is one of those multiple stage questions again. If a load has a mass of 20 kilograms and is subjected to an acceleration of 15 milliseconds over a distance of 30 meters, how much work has been done? Answer A, 5,886 joules, 9,000 joules, 88,290 joules, or little 10 joules as question or answer D. Question number 5 again, if a load has a mass of 20 kilograms and is subjected to an acceleration of 15 milliseconds over a distance of 30 meters, how much work has been done? A, 5,886 joules, B, 9,000 joules, C, 88,290 joules, or D, 10 joules. Okay. I said these are all calculator questions now. Have a go. They're all going to be on the whiteboard when I'm going to give you the answers. So this is part B, questions 1 to 5. So here's my board. How we actually do this question, it's a very simple formula. It's E, or EMF, voltage, equals magnetic flux density, which is represented by a B, the length by L, and the velocity by V. Okay, it's not quite BLT, but BLV. So EMF equals VLV. So all we're doing is simply Times them all out. We've got 2 times 0.2 times 20 equals 8 volts. Very, very simple formula. Now, in the real exam, they may ask you to transpose that around. They may ask you find out what the magnetic flux is or find out what the length is. And all you're going to be doing is transposing that formula. But in this instance, it's just timesing all 3 components out. So question number 1 in second section would be D. Question number 7. What we're looking at is simple, as I mentioned earlier. Apologies. Question number 2 in section 2. So we're trying to find the force. Can we have the big screen up? Thank you. We've got force equals mass times gravity. Now, we were given the mass, we were given 19, but we weren't given the gravity figure. And as I said, that's a figure you just need to remember. It's 9.81. 9.81. So again, simple formula, we're just timesing the mass times the gravity, or in some fit, you might see mass times acceleration, but in this case, the acceleration is the gravity, which is 9.81. So it's just 19 times 9.81, which ends up giving us 186.39. Okay? So the next few are all calculations, so we may as well keep the whiteboard fully up there. So question number 3 of section 2. As I said, this is a trickier one because it's several parts. First part, if we can have the full screen up, please. We're looking at work done. Ultimately trying to find power. Power equals work done divided by time. But first of all, we've got to find work done. Work done equals mass times acceleration times distance. So in this instance, we've got the mass, which was 10 kilograms. The acceleration was gravity again, which is 9.81. And we were doing it over, we were moving that object of a distance by 15 meters. Calculate all those together, multiply all those together, and we get the figure of 147.5 or 147.1.5. As I said, you'll be able to watch this over and over again. Okay, if this is a little bit quick, you're not quite sure how it goes together, because it's on the board, you'll be able to pause it at home later or wherever you're watching this and be able to work through it. Again, cross-referencing it with all the other material we've given you. So that gives us work done. Then all we need to do is put work done. If we go back to that formula, we now need, we've now got work done. We divide that by time, which is always in seconds, and the seconds in this instance was 20. Scrub that. So we're literally now 1471.5 divided by 20 gives us 73.5, or round that up, 74 watts. Okay, told you a little bit complicated. That's as probably complicated some you'll get at level 2 on 602 science. If you can master that, you've cracked it. Okay. Next question, which is question number 4 of our second section. This is all about efficiency. Simple formula, efficiency equals output over input. Okay. What we're trying to find is input. So we're basically moving this or transposing this formula to give us input equals output over efficiency. And if you just think about it logically, anything or any output has got to be smaller than the input. Think about a machine. If you're putting power into a machine, a motor, you're not going to get the same coming out what you're putting in, because in that motor you're going to have some losses. You're going to have losses of heat, you're going to have losses of noise. Okay, so the input is always going to be bigger. So when you do any of these efficiency calculations, once you get your answer, just look at it. Is the output smaller than the input, or vice versa? If it isn't, you've done it wrong. So here we've been given 8,000 watts as our output. Our efficiency, we were told, was 60%, which we put that in a formula of 0.6. 8,000 divided by 0.6 ultimately comes to 13,333. And as you can see, that is our input. 13,000 is bigger than 8,000. So it might not be right, but it possibly is, or it could be, because it's bigger. Okay? If that ended up being, I don't know, 6,000 for argument's sake, we know it can't be right. Your input has always got to be bigger than your output. So that's answer for number 4, section 2 would be D. So question number 5 in section 2 is again a forces one. So we'll go for, it's about work. It's trying to ask you what is the work. So again, work equals mass times acceleration times distance. Now I'm doing a little shortcut here, because what you can do is a bit more long-winded. Force equals mass times acceleration, and then work done equals force times distance. However, you can just do as I've done, cut out this stage, and it makes it a lot easier. Then you're just doing mass times acceleration times distance. It's just one less stage to do. All we're doing then is popping in the numbers. We have 20 kilos. We were given an acceleration this time, so we don't have to know what gravity is. We were told it's an acceleration velocity, that's our acceleration, of 15 milliseconds per minute squared, times a distance of 30. And again, we're just multiplying all those numbers out, and that'll give us a nice now round number of 9,000 joules, because that's the unit of work done. It used to be called like Newton meters, because newtons and meters still is in some books, but the modern terminology is joules. Okay, so the answer to question number 5 of section 2 is B. Pause there. Okay, let's move on to section 3 with the questions. So we're going to resistor questions now. All excited by that. If you have 3 resistors in parallel, all with a value of 60 ohms, what would the overall resistance be? For those of you who watched some of these videos before, we've done some on resistors in parallel, and there are different ways of doing this, and I'll show you when I do the answer a couple of different ways. So answer A is 180, answer B would be 60, answer C would be 20, or answer D would be 10. Just to go over that again, question number 1, if you have 3 resistors in parallel, all with a value of 60 ohm, what would the overall resistance be? A, 180, B, 60, C, 20, or D, 10. Just to let you know, in the real exam, you get about a minute and a half per question when you're answering them, which is ample time, to be honest. Doesn't sound a lot of time, but it is. Gives you plenty of time to read the question properly, look at all the 4 answers, do your calculations, and then make a decision on that. Obviously, what you won't have is an annoying person like me talking in the background, going over the questions and the answers. It'll be nice and quiet in there so you can focus. Question number 2. If a single phase load of 2 kilowatts, that's at K again, Okay, it's 2000 watts, but we summarize it or make it smaller to 2 kilowatts, is connected to a 230 volt supply. What would the current be? A, 460,000 amps, a lot of amps. B, 8.69 amps. C, 0.115 amps. Or D, 2,230 amps. Question number 2, if a single phase load of 2 kilowatts is connected to a 230 volt supply, what would the current used be? A, 460,000 amps, B, 8.69 amps, C, 0.115 amps, or D, 2,230 amps. Question number 3. What is the total resistance of a parallel circuit using 5 50 ohm resistors? So 5 times 50 ohm resistors. A, 10, B, 250, C, 55, or D, 45? Repeat that again. Question number 3. What is the total resistance of a parallel circuit using 5 50 ohm resistors in parallel? A, 10, B, 250, C, 55, or D, 45? Question number 4. Here's a little tricky one. Another two-part one. What would the current be? It's all Ohm's law. What would the current be in a circuit if there were 2 resistors in parallel, 40 ohms and 60 ohms? So there's one calculation. Connected to a supply of 48 volts. A, 0.4 amps, 0.48 amps. B, 1.48 amps. C, 2 amps. Or D, 1,152 amps. Repeat that again. Question 4. What would the current be in a circuit if there were 2 resistors in parallel of 40 and 60 ohms? I said that's one calculation. Connected to a supply voltage of 48 volts. A, 0.48. B, 1.48. C, 2. Or D, 1152? I said the beauty of these, as we've said many, many times, you'll be able to watch this over and over again. You're not just having this lesson in a classroom and you don't quite understand it. Maybe a lot of guys in the class, really got it, and the class is accelerating. If you don't quite get it, you've got to leave that classroom. You'll never see it again. Here, you've got the beauty of sitting in your bedroom or your kitchen table or wherever it is you're watching it, and you can watch it over and over again. Pause it, do that calculation, come back to it, and make sure you understand it thoroughly. So when you come into the centres, you're going to crack on. Don't forget all the recordings we're doing. They are all recorded, and they're all on your student website. Question number 5. Another resistivity one. What is the resistance of a cable if it's 60 meters in length, 6 millimeters square cable, and has a resistivity of 1.78 microfarads? Slightly different, this, isn't it? We haven't used the 10 point to the power of something. We've used the word micro. So you need to know what micro means. A, 0.178. B, 17.8. C, 1.78. Or D, 1,789. I'll repeat that again. Question number 5. What is the resistance of a cable if it is 60 meters in length, 6 meters or 6 millimeters squared cross-sectional area, and has a resistivity of 1.78 microfarads? A, 0.178. B, 17.8. C, 178. Or D, 1,789. And again, it's one of those questions, you've got all the answers. They've all got 17 and 8s in them. Very easy to press the calculator, put the wrong decimal place in, and suddenly you've got a different answer to what you were looking for. Okay. I said that's the beauty of going back to the recordings, watching these live, because if you've made a mistake, you can go back over and over again and watch it again to make sure you get the right answer. Okay, let's do these answers. Go back up. So this is section 3. Question number 1. If 3 resistors in parallel all have a value of 60 ohms, what would the overall resistance be? 2 different ways you could do this. If the resistors in parallel, can we go to a big screen, please? If the resistors in parallel all have the same value, all you're doing is dividing that one of the resistors by the totals. So what I mean by that is they're all 60 ohms. You got 3 of them. So you literally just divide 60 by 3 and it'll give you 20 ohms. Beautiful, easy. However, a lot of the time in the exam, you don't get them all the same value. So you need to know the formula. The formula which I prefer, and I've showed you before, is 1. So the resistance total is 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. What we're doing by that, we're doing 1 divided by 60 plus 1 divided by 60 plus 1 divided by 60. 1 divided by 60 is 0.01, whoops, hang on, do that again. 0.016 plus 0.016 plus 0.016. Add those together, and that will give us 1 over 0.05. 1 divided 0.05 miraculously gives us 20. So it gives you the same value, same answer, but the first one was much easier. If they're all the same value, if they're not the same value, you've got to obviously go long-winded, because these figures could be, 30, 50, and 60. So there's 3 different ones. So you'd have to do this long-winded method. But if they're the same value, you can literally look at one of them, divide them by 3, 4, whatever it might be. I think that's the answer for number 1 in part 3 is C. Question number 2 in part 3, the answer is B. Simple one, this one. We're talking power equals volts times current, P equals VI. But we're not looking for P, we're going to transpose that around. So it becomes I equals P over V. And then we're just a matter of putting numbers in. Power, we were told, is 2000. Divided by voltage, we were told, is 230. 2000 divided by 230 gives us 8.69, which you'll find was answer B. So number 2 in section 3 would be B. Question number 3. Resistors in parallel again. Same as before, we've got 5 resistances, all of the same value. The easy way of doing it, as I said, 50 divided by 5 gives us 10 ohms. Yeah, simple as. So the answer would be A. Or if you want to do it the long way around, I said 1 divided by 50 gives us 0.02. Times that by 5, because there's 5 resistors, gives us 0.1. 1 divided by 0.1 gives us 10 ohms. It's the same, exactly the same, but that's the easier way of doing it if they're the same value. So question number 3 in section 3, as I mentioned, would be A. Question number 4, again, a simple Ohm's law calculation. If we start with V equals, voice went down a little bit, didn't it? Volts equals current times resistance, classic Ohm's law, but we want to find what the current is. So we transpose that around, gives us I equals V over R, and then we just pop it in the numbers, as we always do. 48, which was the voltage, divided by the resistance of 24, and gives us a nice simple 2 amps. Now, how has he done that? You're also shouting out, well, where did you get the 24 from? There was no 24. Exactly. I did a little shortcut there, didn't I? What we should be doing, we need to find the resistance. We've got to do the resistors in parallel. So we had a resistance, so 1 over RT equals 1 over what we had, 40, plus 1 over 60. 1 over 40 is 0.025, plus 1 over 60 is 0.0166, which gives us 1 over 0.0416, which ultimately gives us 24. That's where I got my 24 from. I was waiting for one of you to shout out, where's that 24 from, Gordon? That's where we come from. If you remember when I was saying the questions, it's a two-parter. So you do this part first to find your resistance, then you can pop it in to the nice, easy Ohm's law calculation at the beginning. Always keep ahead. So the answer to question 4 in section 3 is C. For all those listening on a recording, okay, you can't see the questions being scrolled down, but you can hear my voice and you'll be able to hear the downloads when we put them up later. So the final question in section 3 is question 5. And again, it's one of our lovely resistivity ones. We've done a few of them now, so you all should be pretty much experts in it. Come on, let's shout out the formula. Resistance equals resistivity. Come on, George. What's next? Length. Excellent. Times A. Brilliant. So we have got, now, if you remember, in the question, it said micro, not minus 10 or anything, did it? Micro means minus 10. Just as I mentioned earlier, but kilo is 1,000. Okay. Micro is like a million, but a minus a millionth. Okay. If it was a million, it would be 10 to the power of 6, but a millionth is 10 to the power of minus 6 micro. So we have got 1.78 micro, which is, as I said, 10 to the power of minus 6, times the length, which was 60 meters, divided by, it was a 6 millimeter squared. And we all know by now, the millimeter squared becomes 10 to the power of minus 6. And look at this, just like I said before, minus 6, minus 6, cancel those out. So it just leaves us a much, much easier calculation now. You're not messing around with that little fancy button on your calculator. You can actually do that. 1.78 times 60 divided by 6, which should give you 17.8 ohms. If you remember, there was lots of, the answers were all variations with 1s and 7s and 8s in. If you didn't know the micro bit, and you didn't know it was minus 6, then you'd get a different variation of that answer. Okay, that's why it's important. If you go back to one of our early presentations when we talk about SI units, micro, kilo, milli, we should know those. And certainly part when it's one of the first lessons in your TMA 1, 2 or something like, I forget now, but it's very early on in your studies, you'll learn all about the SI units. Okay, so the answer for question number 5 in section 3 is B. Okay, let's move on to the last section. So this is section number 4, question number 1. An electric heater dissipates a power, we've got a spelling mistake, a popper of 3 kilowatts, 3,000 watts, when connected to a 230 volt supply. The resistance of the heater is A, 13 ohms, B, 15.65 ohms, C, 17.6 ohms, or D, 35.2 ohms. Just repeat that again. An electric heater dissipates a power of 3 kilowatt when connected to a 230 volt supply. The resistance of the heater is 13 ohms for A, B 15.65, C 17.6, or D 35.2. Don't forget, all this information is it's all part of your center study link. If you've got one of those, if you've got further down the line when you've done your initial TMAs and your pre-assessment health and safety, you'll get a link to your center study, and part of that is not only all these videos, training videos you need to watch. You get access to your smart screen material and your trades job material. All of those you need to work through before you'll get access to, or an invitation to, the centres when they open up, in order for you to come and do your actual exam. Okay, we need to make sure you're fully prepared before you come in there. That's why you've got to go through all that material we put in your centre study. Question number 2, a machine has a power output of 1200 watts or 1200 watts. The input current is 4 amps and the voltage is 475. The efficiency of the machine will be A, 50%, B, 80%, C, 85%, or D, 90%. Let's repeat that again. Question number 2, a machine has a power output of 1200 watts. The input current is 4 amps. The output, the voltage is 375, and the efficiency of the machine will be A, 50%, B, 80%, C, 85%, or D, 90%. Question number 3. What is the total voltage of the circuit if supply current is 10 amps and there are 3 resistors in parallel of 15, 20, and 25 ohms? Would it be A, 600, B, 0.16, C, 6, or finally D at 64.1? Again, this is going to be a tricky one where it's a two-parter. What is the total voltage of the circuit if the supply current is 10 amps and there are 3 resistors in parallel of 15, 20, and 25 ohms? A, 600, B, 0.16, C, 6, or D, 64.1. I said you'll be invited into the centres once you've done all the material in your centre study. If you haven't got a link to your centre study, it means you're just not quite there yet in your TMAs. But once you get to that post pre-assessments, TMA 9 and onwards, you'll get invited into your centre study. You get a link to your centre study and you start doing all this excess material, recording, watching the videos, doing your City and Guilds and your trades jobs mates. Question number 4, a 10 kilowatt load draws a current of 25 amps. What will the voltage be? A, 230 volts, B, 400 volts, C, a huge 2.5 megavolts, or D, 0.4 volts. Question number 4 again, a 10 kilowatt load draws a current of 25 amps. What will the voltage be? A, 230 volts, B, 400 volts, C, 2.5 megavolts, or D, 0.4 volts. And finally, the last question in section 4, how long would it take approximately if a 20 watt motor lifts a load of 10 kilograms a distance of 15 meters? So this is a multi-stage again, and you have to do some transposition. A, 74 seconds, B, 3,000 seconds, C, 7.5 seconds, or D, 62 seconds. To repeat that again, how long would it take approximately if a 20 watt motor lifts a load of 10 kilograms a distance of 15 meters? A, 74 seconds, B, 3,000 seconds, D, 7.5 seconds, or D, 62 seconds. So there's a lot of calculations, that one. I can see you're all taking a little bit of time to do that one. So like I said, the whole point of this thing is to give you practice of what type of questions, real questions, they'll be like in your GOLA online, your 602 exam. And just to reiterate that, it'll either be in week 2 or weekend 5, depending on what pathway you're going to be on. As I said, you'll be in a little booth, A, B, C, or D for all your questions, and all these are at the same level as what your 602 will be like. Okay, so let's go through the final 5 answers. Back to my trusty board. Some tricky ones there, actually. Some quite tricky ones. So, what is the resistance in a formula, in a circuit, if we've only been given the power and we've been given the voltage? Well, the formula would be P equals V squared over R. Transpose that around, it will give us R equals V squared over P. V was 230, so it's 230 times 230 divided by 3000 will give us 17.6 ohms. Just for a little thing, I'll do that in brackets up here. 230 times 230 is 52,900 divided by 3000 will give us 17.6 ohms. So the answer for question number 1 in section 4 would be C. Question number 2 in section 4, it's an efficiency calculation again. However, with a little twist. Remember what we said the last time? Efficiency equals, I'll just do it by letters, output over input. You sometimes see that. If we can have the big screen up again, if we can. Just wait, there we go. Efficiency equals output over input, or O over I. Nice simple way of doing it. Now the output, we were told we had 1200 watts, but the input, remember we didn't get a wattage, we got just a current and a voltage. So we've got a little subcalculation to do there. Power equals volts times amps. Okay, so in this instance, we've got 4 amps times 375 volts. Whoops, move that down again. So 1200 was our output. Our input was 1500. Now remember, as I always said, the input must always be bigger than the output, and it is in this case. Output on the top, input on the bottom. So it's 1200 divided by 1500 gives us 0.8, but as in efficiency terms, we always times that by 100 to give it a percentage term. So we're talking about 80%. So the answer for question 2 in section 4 would be B. Okay, let's give this a good clean. This getting very dirty. Question number 3 in section 4. Another little tricky one. It's a 2-parter. It sounds easy to start with because it's basically just Ohm's law. You know, voltage equals V times R, isn't it? Voltage equals current times resistance. Current, we were told, excuse me, is 10. But how do we work out the resistance? Just wait for the big screen to come back. How do we work out the resistance? Well, in this instance, we've been given it's 3 resistances in parallel. We've done this before. This time they're different, so we have to do it properly. So 1 over RT equals 1 over, 15 plus 1 over 20 plus 1 over 25. Work those out, it becomes 0.066 plus 0.05 plus 0.04. Add those together and we end up with 0.156. So 1 divided by 0.156 gives us 6.41. So that's our total resistance. We can then feed that back into here. 6.41. So it becomes 10 times 6.41, which gives us 64.1 volts. So the answer to 3 would be D. So it's two-parter. Answer D for question 3 in section 4. So question number 4 in section 4 is a nice simple equation. We're looking for the voltage, and we've been given, if we think of power equals voltage times current, and we're looking for voltage. Okay, big screen will come back any second. So we've got power equals volts times current. Move that around, transpose it around. So important you get to know how to do transposition. If you look, we've done a live recording, how to do transposition, or it's an introduction to transposition. It'll certainly point you in the right direction. Practice makes perfect in this case. Voltage, so it becomes voltage equals power divided by current. The power we were told was 10 kilowatts, or 10,000 watts. So that's 10,000 divided by the current was 25. 10,000 divided by 25 gives us a beautiful 400 volts. So the answer to question 4 in section 4 would be B. And finally, and we've left a nice juicy one to the last, we've got another transposition, and we've got a multiple part. If you remember one of the early ones, if we can go back to the main screen, we talked about power equals watts work divided by time, and work is mass times acceleration times distance. Okay, what we're trying to find now is time. So we got to transpose that around. Basically, you just basically swapping these around. So time equals mass times acceleration times distance divided by power. Same formula, but we just transpose it. Once we've transposed it, we're just popping in numbers as we always do. Mass, we were told, was 10 kilograms. Acceleration is our good old friend gravity, 9.81. Remember that number, never forget it. The distance is 15. We were told the power, excuse me, was 20 watts. So it's basically 10 times 9.81 times 15 divided by 20 gives us the grand total of 74 seconds. And again, remember, so the answer for number 5 is A. Remember, a lot of those answers in there were all 74, 740, 7.4. All you need to do is make a mistake on one of these, giving it a wrong decimal place, or divided by 200 or whatever it might be, and you'll get that decimal place in the wrong. Okay, so the answer for B, or sorry, question 5 in section 4 is A. There were some really tough questions in there, really tough questions. However, they're all very typical, okay, of what you're going to be finding when you come into the centres to do your 602. So it's really important, but you watch all the recordings, what we've put online, and you'll see on there, we've got ones on Ohm's law, we've got ones on resistivity, we've got some on force. Everything we've done today, you will find parallel resistors, you'll find a live recording on that training centre, okay, when you go on your website, student website, okay, there's probably about 50 on there now, and they're all worth watching, because you need to watch them over and over again, because they've replaced your theory lessons in the classroom, and they're much better because you can watch them over and over again. Okay, so when you come into the centres, when you be invited into centres, you'll be expected to know everything now, because you've got so much information, not just on the live recordings, but on your smart screen and your trades jobs mates as well. So if you haven't thoroughly studied everything, the chances are you're putting yourself at risk of failing. That's not what we want. Okay, so we've been given some great news, as you've probably all heard now. The centres we've been allowed to open from March the 8th. So invites are going to be going out, but you'll only be invited if you've completed all the necessary TMAs, the tutor marked assessments, and you've completed all the necessary centre study, all the stuff we've been talking about on this programme and many times before. So go through the centre study, make sure you do all of it, not just tick through it, because like I said, what you don't want to do is just tick through thinking you've been a bit clever and got through, got an invite, and then you fail. Because all you're going to do is go back of the queue and start again. Okay, so when you come into the centre, you make sure that you thoroughly understand the topic you're going to be taking that exam for. It's vital you study all that material in your centre study. So when you come in, you're going to pass first time. I want you to pass first time. Everybody here has put a lot of effort in to help you get through. So we get you through this course as quickly as possible. So we get you out as a trained, qualified electrician. So you can be out there building a future for us all. Okay. So thank you for attending. One last thing, as I always do, please leave some feedback. It's the first time I've done this in total, so I'll be very intrigued to see how I've done. You know, I get a little gold star or not, but always leave a bit of feedback. It's always good for me, not just for me, but everybody else who puts this together. We've got more of these coming on next week. So as always, stay safe, have a great weekend, and I look forward to seeing you on the next one. Bye for now.